Term 2, Unit 4, Electric Charge and Electric Current. What are the learning objective of this lesson? In this lesson, you are going to learn about what is electric charge, electric field and Coulomb's law, and you are going to explain what is electric current, voltage, resistance and Ohm's law. And you have to know what are the different electric circuits, what is series circuit and parallel circuit, and what is the effect of electric current like heating, thermal effect, chemical effect and magnetic effect, and what is direct current and alternating current, and what are the safety aspects related to the electricity. These are the learning objectives of unit. We all know that the fundamental properties are mass, length, time. Similarly, electric charge is also a fundamental property of matter, and matter is made up of atoms and molecules. And now we are going to see what is inside the atom. Atom consists of proton, neutron and electron. Proton plus neutron is called nucleus. Around nucleus, electrons are revolving. Is it right? And electron is negatively charged and proton is positively charged. Neutron do not have any charges. And what is electric current? Moving of electric charge is called electric current, and electricity is a source we use every day, right? In this chapter we are going to learn what is electric charges, electric current and electric circuits. And what is electric charge? This is a basic question. What is electric charge? So inside each atom there is a nucleus. Am I right? There is a nucleus with positively charged proton and neutrally charged neutrons. Yes, and many electrons are revolving around the nucleus. And if you remove this electron from atom, if you remove the electron from the atom, what will be remaining? Only the positive charge will be remaining. So that is called positive ion. And keeping the electron inside the atom and removing the positive charges, what happens? Only the electrons will be remaining inside. So that is negative. That is called negative ion. Okay, understood what is positive ion? And removing of electron is remains positive ion. Removing of proton, it remains as a negative ion. And if you want, you can take down some examples of positive and negative ion in your fair copy. And now we will see how to measure these electric charges. So what are the electric charges? We know that positively charged and negatively charged and neutral charge. So how can we calculate this or measure this electric charges? So what is the unit of this electric charge is Coulomb, and it is written as capital C. And in numeric terms, the charge of electron, we are going to see about electron, that is negative, that is written in the small letter E, and it has some value which is 1.6 into 10 to power minus 19 Coulomb, that is denoted by C. Okay, indicates we can use E or Q. Yes, now we are going to write the fundamental unit of electric charge E. We can write Q is equal to NE. What is this N? Whole number. And what is that Q we have written here? It is any charge. Any charge is written as Q, and integral multiply, that is any whole number is N, and electronic charge is E. So Q is equal to NE. If you notice this problem, how many electrons will be there in 1 coulomb of charge? Okay, now we are going to calculate how many number of electrons in 1 coulomb. So now what is given here? Coulomb is given. What you are going to find out? Number of electrons. So we need to calculate numbers. So N. So from Q is equal to NE, we are going to find out N. So we have to rearrange the formula. So now Q is equal to NE will become N is equal to QE. We know the value of Q is 1 coulomb, and we know the value of E. What's that? 1.6 into 10 to power minus 19 coulomb. On simplifying this, 1 coulomb consists of 6.25 into 10 to power 18 electrons. It consists of 10 to power 18 electrons. Okay, and if you see, the coulomb has three varieties: microcoulomb, nanocoulomb, picocoulomb. Okay, what's that micro? The value of micro is 10 to power minus 6, nano 10 to power minus 9, pico 10 to power minus 12. Okay, then total electric charge of a system is algebraic sum of charges located in the system. So how many charges are located in a particular system, that is the total electric charge. The sum of all the charges is called total electric charge. And small example is given. If a system consists of two charges, plus 5C and minus 2C, and how could you calculate this? You have to sum both. So notice here, plus 5C sum of minus 2C. So plus into minus is minus. So 5 minus 2 is 3C. Have you all understood? And next, electrostatic force. You know what are the different types of force. In that, electrostatic force is also a very important force. Electrostatic force between 2 point charges obey Newton's third law. What's Newton's third law? For every action there is a equal and opposite reaction. Now we are going to see. So far we have seen what is electric charges and how we have to measure the electric charges. And we know that what is microcoulomb, nanocoulomb and picocoulomb. And we have solved one problem. How many electrons in 1 coulomb of charge? And next is electric force. We know that force. What's a force? Push or pull. And this is electric force. Among electric charges, there are two types of electric forces. One is attractive force, another one is repulsive force. So this is also like a push and a pull. You know that there are two types of charges. One is positive charge, another one is negative charge. If both the positive charge attract each other, okay, both positive charge comes together, what happen? It just go away. So like charges repel, opposite charge will be attracting. What is the opposite charge? One positive and one negative. If you notice this, plus and plus, both the plus charges are coming nearby, but it goes in a opposite direction. It does not attract. Similarly, minus and minus. So what happens? It will not come together. It will go. That arrow mark indicates the direction of the charges. So like charges repel and unlike charges attract. One positive and one negative alone will attract each other. Like charges will not attract, it will repel. And what is the definition of electric force? The force existing between the charges. So the force existing between, what makes them to repel or attract? That is force. So it plays between the charges. So it is called electric force. Have you all understood? And next is electric field. What does mean by electric field? The electric line of force or straight curved path along a unit positive charge tend to move in an electric field. What do you understand from this? If you see, the region in which charge experience an electric force form an electric field. So if you place a positive and negative charge, there will be electric field because there is an electric force. So wherever there is electric force, there will be a electric field around that charge. So electric field is denoted by the letter E, represented by line and arrowheads indicating the direction of the electric field. And we already know that where there is the electric force, there will be a electric field. So direction of force will be the direction of the electric field. Okay, acting on a small positive charge. you should remember here this electric fields are talking about positively charged particles, and we have read out the definition of the electric field. And what is that electric line of force? We cannot see by our naked eye how this force act, so we just imagine to like they can form a straight line or a curved path or a circular path, so which is given in this picture. And if you see that, look at this picture, see first one is positive charge, is it? First one is positive charge and force will be going outward. The direction of the arrow mark is away from the positive charge. And if you see B, it is inside towards the negative charge. And see positive and negative charge, what happens? It will attract. So the line of force, the force may be from positive to negative. Is it right? From positive to negative, and beyond that it will go outwards. And see the last picture, positive charge, what happens? It go away because like charges will repel. So how to measure the electric field at a point, at a particular point? How can we measure it? Force acting on a positive charge place that point. So I'm again and again insisting, where there is electric force there will be a electric field, and the force acts on the positive charges. Okay, force acts on the positive charges. Next we will discuss what is electric potential. Though there is an electric force existing among the charges, they are still kept together, is it not? What's that meaning? Though there is an electric force, attraction or repulsion, so some keeps them together. What's that? So the region of electric charges, there is an electric field. Other charges experience a force in this field. So there is a work done on the charges to keep them together. Except that force, some other one quantity is there to keep that charges together. That quantity is called electric potential. What's that? Quantity is called electric potential. So if you see this, higher electric potential, lower electric potential, this is a uniform electric field. Okay, this is a uniform electric field. So positive will move this side, there will be a higher electric potential. In negative side, it will be lower electric potential. So what is now electric potential? Measure of work done on unit positive charge to bring it to that point against all electric forces. To bring a positive charge to its previous place against all the electrical forces is called electric potential. Okay, and this is, we have given in this picture both electric field and the electric potential. So towards positive we have the direction. What's that? Blue color arrow mark is a direction of positive charge, and near plus and minus, the blue color arrow mark is a direction of, what's that? Electric field.